Yes. So, okay, we started talking about the types of data, right? So we said that you have numerical data, correct? And numerical data can be your discrete continuous. We saw the difference between discrete and continuous. Continuous, you can have again interval and ratio. Okay, so interval is where you talk in terms of interval, kg, temperature, okay, height, okay, time. All these are interval data, okay?
Mm.
And based on our requirement, we choose the interval. So if you need to have weight in kg, then our interval is like multiple of 1 kg. If you want to have in grams, then it will be multiples of gram, right?
Oh,
So we discussed, right? Person's weight probably will measure in kilogram. But if you're measuring
mm.
gold, you'll probably measure in, even much smaller scale.
Mm.
Okay. Okay. And then we discuss continuous data. So that's interval. And then ratio is with respect to, right? So when you say 29%, okay, or when you say 31%, so that means there is something which is 100%. You want a portion of it. Okay. So your continuous data can be, okay, can be
Yes,
interval
with
or,
ratios and
yeah,
ratios.
yes. And then, okay, so we will talk about scatter plot, but just for introduction, okay, just give me a second. Give me a second. Okay, so that's a data type, right? Now to visualize the data, again, you need to understand in what should be the visualization form, right? We have different types of graph, and the graph, you can't draw or you can't plot anything on any graph, right? So this scatter plot is the best way to plot, okay, numerical data. So when both x, y axis, see, when you talk visualization, okay, and when you do visualization on your computer or on paper, even though in data analysis and data science, we'll talk about multiple dimensions, okay, dimensions where you have multiple axes, but you can't visualize, you can't put multiple axes on computer, right? I mean, to visualize, to see, it'll be just
Mm.
two at a time. It's a two-dimensional, right? So you'll have at least only two at a time. You can choose which two axes you want, which two features or which two columns you want to show. You can choose, but you can only show two at a time, isn't it? So you have
Yeah,
x-axis and y-axis. So when
right.
both x-axis and y-axis are numerical, then scatter plot is the best way
Best.
to,
Mm.
yes. So what do you do here? Okay, so each point represents two values. Each point represents value on x-axis and on
Mm.
y-axis,
Yes.
right? Sorry.
Okay.
So each point represents two values, right? One value on x-axis and other value on y-axis, correct?
Mm.
Yes. So this is the plot to draw. Now, when we go to categorical data, we discussed about two types of values, nominal and ordinal. Nominal,
Ordinal.
so first of all, what we said was categorical values are categories of values, right? So when you talk about the data is categorical, that means it would be one of the given categories, right? You cannot have values which is outside of category, right? So here
Yeah.
example, you see gender, male, female. So write two options. You can have zone, north, south, east, west,
It's true.
or let's say
Mm.
companies of car making companies. So you have the six
So it
companies.
should be relatable.
It should be relatable, but category doesn't say that it should be relatable. See, the
Yeah.
values,
Okay.
what you capture, okay, when you say column, when you say age, name, gender, region, that means the column is always relatable,
Common. Hmm.
right?
Okay.
And this is
Mm.
what we discuss in database, that your column is always same type of data, same relatable. Rows
Yeah.
will have different values, but they're related to same record.
Yeah.
Okay, if you look at
It's
a
like
row,
hour basis, day basis,
yes, so when you talk
right?
about,
Year
say, employee
basis.
day table, so you have
Hmm.
name, phone number, email ID, all these data are different. But similarity is
Different,
that
right?
they belong to same individual, same person. right?
Yeah.
Now, when you talk about column, name, so everything has to be name, date of birth, everything has to be date of birth, phone number, it has to, company, it has to be all companies' name, isn't it?
Hmm.
So that's what we say categorical data. And then you have nominal, which it does not have any order, so it doesn't matter whether you put Maruti first or Tata first, right? Or Mahindra first, it doesn't really matter. Okay. Then you have ordinal where order matters. There again, categorical data,
Yeah.
but here order matters. So you cannot have poor, good, fair, excellent, very good, right? Either you say poor to
Yeah.
excellent or excellent to poor, right? So these are where order, categorical values where order is important is called as ordinal data.
Ordinal.
Okay.
Hmm. Hmm.
So this is one of the important graph that we create when you have one side you have categorical and other side you have numerical. So both the sides scatter plot. When you have one side categorical and one side numerical, then it is frequency graph is important,
Graph.
right? Right. So here what you do
Yeah.
is category, right? Unique values. So you're counting how
Hmm.
many such categories are there. So there are 73 values of accounting. 36. So this is data of 200 students in a business school getting placed. So they're looking at which department they got placed, right? So they got placed in
Hmm.
finance department or accounting or general management or sales. Okay. So this talks about different types, and then this talks about the number of people falling in that category.
A particular category.
Category, yes. Okay. And this
Particular
is your
department.
relative frequency. You can draw even a pie chart.
Pie chart.
Pie chart talks about the contribution, right? So you can
Yeah.
do frequency chart, you can do pie chart. Okay, when you have categorical data versus numerical data.
Hmm.
Okay.
Hmm.
Now, since this book was written for a university student, so there's a this one for them to prepare for the exam. You don't have to go through it as long as you understand what each of these things means. But of course, you can read it to get a better understanding of the different data types. Okay. So, okay, yeah. Then there are other types of data. Okay, we have time series data. Now, time series data talks about data which changes with respect to time. Okay, so if I say sales, right? Now, sales is not one number, because when I say sales, question should be, are you talking about hourly sales, daily sales, weekly sale, monthly sale, quarterly sale, annual sale, right? So if it is annual sale, value will be different. If it is daily sale, values will be obviously different, right? So
Otherwise different.
so data that changes with time is called time series
Time
data.
series data.
Okay. So
Yes.
that's one. So it's a numerical data. It's a special type of numerical data only. Okay.
Okay.
Yeah. Okay. And then you see the text data.
Text. Okay.
Okay.
Hmm.
So text data, okay, obviously it means you have text in it, right? And with text, there's a limited thing that you can do. You can't, of course, do multiplication, addition, or none of the mathematical operation you can perform when data is text data.
Text. Yeah.
Right? So
like when we have no numbers in text data, right?
yes. Okay. Like sentences, tweets, your Facebook
Okay.
post, right? These are
All
your
right.
text data, right?
Yeah.
So, okay. So text data, so we have something, there we can perform what is called word frequency. Okay. Sometimes you will see that, we look at somebody's speech and you want to see which words is repeated most. We call them as word cloud and things like that. Okay. So you can figure out that's one thing. Okay, your sentiment analysis, whether it's positive sentiment, negative sentiment. Okay. Then you have language translation. You want to translate into one language to another language. Okay, spam filtering, right? Your email, you have spam folder, right? So your Google actually does that spam filtering, correct? So these are different activities, that operations that you can perform on a text data. Okay, so mostly we'll be dealing with these four types of data, but mostly we'll talk about numerical and categorical. But yes, we will touch upon time series as well as text data, yes, in our work. Okay, now talk about the essential statistics. What are the statistics template or metric that we generally use with data? So statistics are of two types. Okay, one is called descriptive statistics, and second is called you have descriptive as well as inferential statistics. Okay, inferential statistics is where you infer the information from the given data. Okay, so you cannot actually calculate, right? But you can infer the data. Okay, so okay, so let's say you interview. Okay, you ask 10,000 people, okay, which party they are going to vote, correct? And based on the response of 10 respondent, you are giving the seat distribution, right? You're telling which party is going to win the election, right? So you have crores of people who is going to vote, but within the response of 10,000, 20,000, 50,000, you're able to extrapolate that. That is called inferential. Okay.
Okay. Like taking some samples and giving the output based on that.
Exactly. Okay. So that's called inferential statistics. Okay. But the descriptive statistics is where you work with the entire data set. Okay, you work with the entire data set. Yes. Okay, so now for now we'll focus on our essential statistics, which is mostly descriptive statistics. Okay, so in descriptive statistics, okay, you have two types of data. First, we look at what is called as measure of central tendency. Okay, measure of central tendency. Okay, so I'll just ask you a question and see how will you respond. Now, okay, how many hours do you sleep? Okay, that's my question.
In a
Sorry?
day? In a
Yeah,
day?
yeah, per day.
Per day, 8 hours.
Right? So your answer is on average, right? Sometimes you might have slept more than 8 hours. Sometimes you might have slept less than 8 hours also. Right? So what you're saying is, okay, instead of saying that, oh, yesterday I slept only 5 hours, day before I slept 20 hours, before that I slept 10 hours, then before that I slept 3 hours. Okay. Now, one simple question, you don't know how to answer, right? So what you do is, so to make it easy, what you say, on average, I sleep 8 hours per day. On average, I sleep 8 hours. So, okay. So when you say on average, okay, it means that, okay, it is on average, right? It is never 8 hours.
Yeah.
Okay, it is never 8 hours, right?
Yeah.
Average number doesn't mean that it is exactly same every day. Okay, the moment you say average, it means there has to be value more than average and a value less than average. Yes, it cannot be exactly 8 hours. That's what it means when you say average. Okay, so so understand the average in that perspective. Okay, but it doesn't tell you. Okay, so when you talk about central tendency, this is what we're talking about. How to understand, okay, a central value which can represent the entire data. So
Okay.
central tendency is about one value, okay, which can
Mm,
represent the entire data set,
okay.
right? So when you said 8 hours, you have summarized a data over last 1 year, 2 years data, isn't it?
Yeah.
Otherwise, you had to tell me 365 numbers, right?
Right.
So, but with one number, you have told me the entire thing. So this is what we call a central tendency, which
Center of
represents the, yes. So apart
attention.
from average, you have other metric also. You have mean. Mean is same as average, right? In statistics, we call it as mean, but in general usage, we say average. So you have average, mean, median, and mode. What is median and mode? You must have done in your course, right?
Yeah. So median is also a middle value,
Mm-hmm.
uh, middle value of any number of series.
Okay. So
Correct, na?
correct. It's correct.
Middle
So what you
number
do
of,
is you arrange the order in increasing order,
then I'll
right?
pick
Yeah. And then
the middle
look at
one.
the middle value.
Middle one. And
Yes.
mode like most common number, like
Most
mm,
common, right?
more
Which is
repetitive one.
more repetitive one. Exactly. Okay. So, okay. So this is what, um, the mean, median, mode means, of course. And these are the steps formula to calculate, which, so I can skip it for now.
I forgot.
Yeah.
Yeah.
And, okay. So, and now when you talk about plotting, okay, one second. Okay. So, yes. So, how do you represent the data? Okay. Okay. So this is one way to represent the data on graph table. So this says that there is a bank, okay, and the manager wants to see what is the average service time for each customer, right? Just to understand whether if he or she has to add more staff to the bank, right?
Okay.
So what they do is they say, okay, let me try to see on average. Okay, so probably he'll sit in a corner and note down the entry time and exit time of each customer, correct?
Yeah.
And let's say these are the number of, so you have 20 customers and this is the waiting time they had.
Number
43.1
waiting time.
seconds, 30, yeah, waiting time. And then you plot this data in a bar graph. So bar graph
Mm.
is the best way to represent your numeric data. Okay.
Numeric data. Yeah.
Yeah. So this is one way to represent your data. Right?
Okay.
Okay.
Mm.
Okay. Now there are different.
Uh, can you please turn back the page? So in x-axis, what they have put in 1, 2, 3, 4. Like
Okay.
what is this?
So
I
on
can't unable
x-axis you
to.
have the time.
Okay.
Okay. And y-axis the count. So this is how
Number of
your
customer.
number of
Okay.
customers. So this is how your the frequency graph will look like. The
Yeah.
frequency is about how many. Okay. Count.
Mm. Okay.
Yeah.
Yeah.
And then, okay. And another data to represent is we have seen two types of graph. This is just repetition of what we
Uh,
have seen before. Okay, now the another
Scattered.
data. Okay, now let's look at this data. So this data talks about a shopkeeper. Okay, ice cream shopkeeper.
Yes.
Okay, so this fellow, okay, every day what he does is he notes down the highest temperature of the day.
Mm.
Okay, and the number of amount of sales that he's making in that day per day,
Okay.
right? So on day one, average the maximum temperature of the day was 25 degrees Celsius,
But,
and he sold about 3,400 rupees of ice cream.
uh,
Second day it was 32.8 degree and sold about 4,500.
4,500.
Okay, so now you know, so with this data, okay, we plot this scatter plot. Okay, now tell
Yes.
me, what do you understand from this scatter plot? What does that scatter plot tell you?
Tell us, uh, does the temperature increase, the sale of ice cream were also increase.
Okay, so what is the answer that you get?
Uh, like in highest temperature, we would be selling more, so we have to keep more inventory when the temperature would high.
Mm-hmm.
Uh,
Okay.
like we forecast na like okay, 2 days ago
Right, right. So
what
what
would be
does
the
trend tell you?
temperature,
What
so
is the
on
trend
that
telling you? Yeah, correct. You're right. What is the trend telling you?
direct proportional
Direct proportional. Exactly.
uh,
Okay. So this is what we're talking about. Okay. So when
mm,
one increases, other also increases, we call it as directly proportional.
direct proportional.
Okay. So again, we'll talk about it later as well. So there are three possibilities. Okay, at a high level. Okay, directly
Mm,
proportional, inversely proportional, or no relationship.
yeah,
Okay, in this case, what you see, as temperature increases,
direct.
sales also increases,
It's direct.
right? Right,
Yeah,
it's direct. Okay, had it been reverse, temperature less and sales more.
converse.
Okay, inverse
Mm,
proportional, right?
mm,
And dots are everywhere, right? You can't make up your mind whether it is increasing or decreasing. Then we say
no
it is
relation. No
yes,
relation.
yes. Okay, so that's okay. So that's how
Mm,
you calculate the relationship between two variables. Okay,
okay.
so this is just to visualize. We'll calculate. We'll go step by step. Okay,
Mm,
okay. So let's see the data. Okay, now you look at this data. Okay, what does this tell you? Okay, so this is the household income of people living in US. Okay, so
mm,
left side
mm,
you see you have people with the, so this is the income. Okay, so obviously you can't read the data, but you can make out that the annual
yeah.
income is increasing, right? Here it is closer to zero. So this is 0 to 55K per month per year. This is 55 to 1 lakh. Okay, or yeah. Okay, then 1 lakh to 1.5 lakh. So these are the values which are higher side, and this is the number of percentage of household.
Mm.
Okay, so what do you understand from this data?
Right side value is increased one, right?
Mm-hmm.
Uh,
Obviously,
less,
we'll go from
less.
left to right, isn't it?
I was unable to read the values,
Yeah,
no,
yeah, yeah.
that's why.
I know it's not clear, but generally I'm saying, right? This
So
is
with
how you.
that percent of household, so there are less uh percent of household carry more income.
Right. So so as you look at the household income, as household income increases, the number of people, okay, decreases, right? The percentage of
Decreases.
people getting that income decreases,
It's
right?
inverse.
But at the
Hmm.
end, you see, okay, two big tower, okay, that
Yeah.
means there's more number of people, okay, there.
Um,
So, right,
yeah.
right. So yes, so this is how you look at the data. So right now we are not analyzing the data. We are not performing data analysis. Okay, we simply wants to see the data. Okay, later I'll tell you. Okay,
How we would analyze it.
yeah. Okay, later we'll see how to analyze the data. What does it mean? What is outlier and things like that. Slowly we'll get into that mode. Okay.
Yeah.
Okay. Uh, okay. This metric we don't need to know. Okay. Now, this is something that we need to understand. Okay. So now we are talking about, okay. So we know how to create a frequency table, a frequency graph. Yes. So what will
Yes.
be on x-axis? What will be on y-axis? Can you give me an example?
Uh, like we have department on y-axis and we have hmm,
Count will be on
numerical data.
y-axis. So you have department on x-axis and number of people belong to the department on y-axis. Okay.
Okay, no,
Okay. So,
numerical values on y-axis.
count will be on y-axis.
Yeah, okay.
Okay.
Hmm.
And on x-axis, you'll have the department.
Okay.
Right? Okay. So what does this graph tells you? Let me see.
This first one,
Yes.
I didn't understand
Okay.
this.
So see, this is the frequency table I told you, right? So you have department on x-axis and count on y-axis, correct? What it says is department that you see at the center, this is this department has a maximum number of people. Okay.
Hmm.
That's why you see this tower is big. So mode of this graph is this is the mode. Yes. Whatever is the department, this
Okay.
department is the mode because highest occurring department, right? Highest employee department, the highest employee. That's your mode. Okay. And also when it is symmetric, your mean median mode is same. Okay. So what you see here first is called normal distribution. This is how you have a normal distribution. This is a constant distribution. Okay.
Yeah.
Okay, because all are equal, multimodal or constant, everything is same. Here is bimodal. You have two modes here. And all these are called symmetric because if you put your mirror at the center, you get mirror image, right? So that's your symmetric histogram. Now, taking to the actual analysis, okay, at the center, this is what we said is your normal distribution, right?
Hmm.
Where,
Hmm.
okay, you have median, mean, and
Median
mode,
mode,
all three at the
same.
center. Yes. Okay. And
So this is normal distribution.
correct. Okay. Now, if you look at things around you, okay, mostly it is normal distribution. Okay. Mostly it is normal distribution. Okay. But slowly what happens is, okay, um, um, as you um, move away from mean median, okay, you come across outliers, right? So let's say if you have outliers heavy on the right side. So see, mean median mode is equal means you have data equally distributed over your mean, right?
Okay.
So let me give you an example here. So let's say you have Okay, 5, 10, 10, 15, 15, 15, okay, 20, 20, 25. Okay, now what is the mode here?
15.
Okay, and what is the median here?
15.
Okay, so mode is 15.
Uh,
Okay, your median is also 15 because if
15.
you look at this data,
Uh,
equal number of, right? And average you can take. Okay, so when you have normal data, you see your mean, median, mode is exactly same. All three are same.
same.
But if I add a outlier this side, okay, then things will change.
Okay.
06. See, became 57. Your median will also move slightly towards right side. Two data means somewhere around, so it will be average of 15 and 20. Okay, so somewhere
Okay.
around 17. So you see, as you add outliers, your mean mode will remain same. Mode is not going to change. Outliers means very few such values which are getting added. Okay, so so very few values are getting added. Okay, so mode will not change, but your mean and median will change. Which is changing faster?
Yeah.
Mean is changing faster. Mean will always change faster if I have outliers. Okay, so that's why when
Okay.
you go back to our notes there, what we are looking at. Okay,
Mm.
so this is normal, mean, median, mode, all same. But when you add an outlier on the right side, higher value, see, mode remains same, but mean
Yes,
increased and median
minutes
also
increase.
increased. But mean is increasing much faster than median,
Yeah.
right? Since the tail values are getting added at the positive x direction. So when you look at x-axis, right side you have plus x and left side you have minus x, isn't it? Right? When you look at for quadrant, okay, on x-axis, right side is positive, left side of your coordinate is negative, isn't it?
Yes.
Yes or no?
Yes, yes.
So when you have a outliers on the right side, we say it is
X
positively negative, positively
negative.
skewed. Okay, and
Okay.
when you add outliers on the left side, it is called as negatively skewed.
Yes.
Okay, if you add a higher values, okay, mean and median will go towards right, mean will go much farther, median will go little towards
Oh,
right. Okay, and this is called positively skewed.
okay.
This side, when you look at the data here, you're adding a lower values, so mean is going towards low side, median is moving towards left side, so this is called negatively skewed graph,
Negatively skewed.
right? So you remember
Okay.
the graph that I showed you, average annual income of household in US? What kind of
Ah,
graph was it?
it's bar graph.
Yes, but if you have to put it under these three, which one it would be?
Uh, Positively skewed
Positively
because we have,
skewed, tail on the
because we
right
have,
side. Exactly.
right side we
Tail on the
have
right
some
side
outlier.
is positively skewed graph. Exactly. Okay. So yes,
Hmm.
now, okay, we'll stop here for today. Okay.
Hmm.
The next topic we'll talk about is called measure of variability. And then we'll combine the measure of central tendency that we have done so far, mean, median, mode, and we did
Hmm.
positively skewed graph, normal graph, and negatively skewed graph, right?
Negatively skewed.
Yes. And
Yeah.
now we'll talk about variance and standard deviation. Together, we'll see how to analyze data. Okay.
Yes.
So
So,